How's it going, folks? Decided to make a video actually about the attack disk and the rear side of the attack disk, because there's been some buzz recently on Discord, Wolfpack Discord anyway, about making some slide rules, and there's questions around slide rules and whatnot. And so I decided to make this video, a series of videos detailing the use of the historical attack disk, which is the front side here, plus the reverse side, which is the speed side, known as the speed disk. These two disks in conjunction with one another can get you really from A to Z in an engagement. There's several things you can do with these. Very handy tool. A lot of folks like to use a calculator, a scientific calculator, to do somewhat complex calculations involving trigonometry and whatnot. That can be done using this. This is a logarithmic slide rule with sine scales on it that allows you to multiply and divide and derive sine of angles, etc. Do time, speed, distance calculations. A lot of things you can do with this. I figured what I would do is start this tutorial off with this first video, just detailing what these are, what the various gadgets on here represent, and then also go into in depth a little bit about how to use the speed side here, or the logarithmic side, in order to have a good idea of the why behind why you would be doing the various things you're doing with this, because in conjunction with this, I am going to use the or refer to the handbook that came with, or that was produced for the recreation of the attack disk for the Silent Hunter series, really specifically Silent Hunter 3. This guide is how I learned the disk, and I look back to it frequently if I do want to refresh my memory about how to do specific calculations. But basically, all of these and more is what you're able to do with this with these two disks. Several of these I'm not going to go into in this series because this series is specifically geared toward Wolfpack. And for those of you who are familiar or may not be familiar with the game, you do end up spawning somewhat close to a contact already, and so there's really no need to do some of these longer range, intercept a reported contact, waylay a reported contact. Those of you who are players of the Silent Hunter series, that will be readily clear as to why you'd want to use those particular functions, but I won't go into those at this time, given the fact that there really is no long range, at least if you're talking about a single U-boat, spawning into the game. You're not that far away. It's just a function of finding them, but it doesn't take too long. So anyway, I'm going to, over the series of maybe 4 or 5 videos, I'm going to go through, actually in Wolfpack in the tutorial mode, go through the use of each of the attack disk and the speed side to compute various of these examples from this list here. But first and foremost, what I want to do is just give a little background and sort of generalities around both of these disks. So the first side here, and by the way, this is Solution Solver app is made by Corey Hartwell, otherwise known as Gutted. He is a great tool. The tool is available on subsim.com. It is sort of a combination of many different tools. I am going to focus specifically on this one right here, the attack disk. But it has, and I won't go into all of this, of course. This isn't about this tool. This is more about the attack disk. But it has several features in here that are very, very interesting, to say the least. And so, I would advise you, if you are, interested in using this tool, to search out his videos that cover the entire tool. So, but for our purposes here, we'll focus on this attack disk setting here, and the front side. This is known as the front side, and this is actually a representation of a historical device. This This is the true attack disc right here. The real one did not have a reverse side. It did not have this side. This side here is actually a recreation of an American device, the source of which escapes me at the moment. But suffice it to say, the calculations or the information that you can derive from this particular side in the way of trigonometry solutions. So using basically, it's really all of it revolves around the law of sines. Doing multiplication and doing division, doing time, speed, and distance calculations, doing, like I said, sine functions, you name it. The Germans did have a historical disc that computed speed based on a bearing change over 1 minute. That was known as the Auswanderungsscheibe. That Scheibe being disc or slide rule. Rechenscheibe in German is slide rule. This disc can do that functionality as well as much more, and so it really almost, you can think of it as superseding the other disc. It has a lot more functionality, as you will see. So this is not historical, at least historical to the German Navy anyway, but I think it stands to reason that they would have used, and did certainly use in the case of that bearing change disc that I just mentioned. They did use circular logarithmic slide rules such as this. So this is the two sides of one disc, if you want to think of it that way. You could switch between the two in this tool using this middle sort of axis here, and then there's a button up here to reset the discs. So I'll start with the attack disc side. So there appears to be a lot going on here. It can be a little bit confusing at first, but really what you've got here is really three dials. There's this first one here, the outer, this middle one, and then this inner dial here. So what these are is the outer ring here represents, and it's flipped because what it's doing is it's representing either relative bearing for a particular course or a gyro angle. That's what this is doing here. This disc right here is the compass rose disc. The primary thing that you use this for is to set your own course against this triangle, and I'll demonstrate that in coming videos. But so, for example, if I wanted to set my own course to 070, I would set this as well. So now you can see, as far as bearing is concerned, my course is 70, and I say, okay, I see a target at 10 degrees. I can move this pointer, or really, this is truly the bearing pointer right here. Move this to 10 degrees here, okay, and I can read the true bearing underneath it at 80. So it's 70, 10 degrees off my starboard bow is 80 degrees. So that this is you can already see how handy this is to be able to just readily see true bearing off of relative, based from relative and own course. So this is the really kind of, you want to think of it, own course or compass rose disc, bearing disc or gyro angle disc, compass rose disc, and this is the target disc right here. The word Lage in German means angle on bow. Literally means position or situation, but it means, in the context of submarines and of the German military, it means, or at least German Navy, it means angle on bow. Okay, so you can see emanating from the zero are degrees, either green for starboard or red for port, and just a quick example. Again, I'm going to demonstrate more in the future, but say here we're at that 10 degree bearing now. We're at that 10 degree bearing again. So we say, okay, 10 degrees, and I see and I observe a target with a 90 degree angle on bow right. So I would take this and I would set the 90 to align with the bearing, and I can read off the course. Course is 155. Okay. So again, this is just a quick example, but that's what this is, the target disc here. And of course, this pointer is pointing to the target's true course. So that covers the three discs. Now the pointers, to the extent I haven't covered it already, this here is the bearing and lead angle pointer. The original had the word Vorhalt here, which means lead angle. The lead angle, of course, is emanating from the 0 left and right. Green for starboard, again red for port. That is the bearing and lead angle indicator. This here is the attack course indicator. So this here you'll see in the coming examples, there's really two sides, and there's one thing missing from this, and that is the word Angriffskurs, which means attack course. Okay, so this is the attack course and really in torpedo course indicator. This VORH Bug, that stands for Vorhalt Bug. This is actually used in conjunction with this indicator here to set the lead angle, and the utility of that will be clear in later videos, more toward the end of the series. But this is for no TDC shots. I used this pointer before to derive. You could also use it as a reference to convert from relative to true bearing. But really, or you can use this one for that. But really, what this is meant to do is meant to be used in conjunction with this dial here to set your lead angle and set the torpedo course manually there. So that is really what this is here. Primarily, historically, my understanding was this was primarily used for to derive. If any of you have seen my other videos about no TDC shooting, that the formulas in my Excel file that cover no TDC shooting are essentially what this is doing, essentially in disk form. A little easier to visualize using this than using the Excel file. But this is essentially what that file is doing. The calculations in that Excel file are doing is this, and I'll go over that later in the series. But this is the front side of the disc, purely just angles here. There's no trigonometry or anything like that. It's purely just angles, 360 degrees, allowing you to establish relationships between yourself, meaning the U-boat, the target, his bearing, his angle on bow, and to the extent you want to use this to shoot torpedoes, to set the lead angle, to derive either a gyro angle or an attack course or a shoot bearing, you name it. So that's all fun stuff to come later. So that's this side here. The next side is the speed side. Again, this is not historical to the Germans, this layout anyway, but the functionality is, this technology was certainly around and was used by the Germans as well. There is a lot going on in this disc. There is a lot you can do with this disc, and I would say that probably, I wouldn't say maybe the majority of your time in the examples that I'm going to go through are spent in this disc. Maybe I'm wrong about that, but anyway, a lot of time is spent in this disc. You can derive a lot of information from this. But this is basically pure and simple, a circular logarithmic slide rule that allows you to do division, allows you to do multiplication, and it allows you to do trigonometric functions. And so, just to the overall rule regarding this type of disk is there are certain, if you want to call it, sort of order of operations to use when going about doing a calculation in this. So I'm going to take a look at just a simple example here of division, and then a simple example of multiplication when it comes to using it for sine functions. So, and I'm going to go over these examples in more detail, not specifically these examples, but these concepts, and I will actually shoot at targets in the tutorial later in the series, but just to kind of demonstrate the math behind some of this. If you, for example, want to say, okay, if you wanted to do division, the general rule is, in order to do division on a slide rule like this, so you have your assume you've got a ratio and you've got a numerator and a denominator. Okay, so let's say you're doing a time, speed, distance calculation where you're going to say, I want to figure out the speed of the target based on the distance it traveled divided by the time it took to travel that distance. So the outer dial here is in degrees. The middle dial here is either in meters. This is calibrated for meters. Meters here, speed in the middle right here, and this inner dial is time. So if I want to do division, generally what you do is you take the numerator and you align it with the denominator, and the reference line will point to the answer. That's typically how division works here. So just take as an example, let's say the target traveled, you've plotted the target over time, okay, and you measure, between all, and you plotted over, let's say you plotted over 5 minutes, okay. So here's 5 minutes right here, and you measure that distance on the map to be 1,400 meters. All you do, and so the calculation in your head, it helps to be able to visualize the formula itself, the actual equation, and then you'll know how to use the slide rule. So you say, okay, I know it's speed equals distance over time. So you take the distance over the time, literally. So you say 1,400 line up by 5. And now I go down here, and this reference line is pointing to 9 knots. Boom, done. Calculation's over. So that's division. Okay. Now let's take a multiplication example. Multiplication works a little different. So with multiplication, what you can use the sign scale here. The outer ring here is a sine scale. And if those of you are familiar with the law of sines, if you take the sine of an angle that's close to 90, the answer is very, very close to 1. The sine of 90 is 1. Okay, the sine of 85, the second notch here, is so close to 1 that it's hardly any different. Okay, but the further you get away from 1, down here, you can see the tick marks get wider apart, because the smaller the angle down, the angle you have that you're taking the sine of, the more disparate the answers are, meaning the wider the distribution of answers, versus as you get close to 90, your answers start getting a little tighter. It might be 0.9, 0.9, 0.8, 0.8, 0.8, 0.7, 0.7, and then it's 6, 5, 4, 3, 2, 1. The answers get a little more disparate the smaller the angle is. And so you can visualize that by this here. And so in order to do multiplication, the way this typically works is, and I'll find an example here of simple multiplication in one of these examples. Let's use the constant bearing one again. I'll go over this in more detail later, but basically so this is a simple one here. So part of this calculation is multiplication, part of it is division. So this one you'll be able to see both in conjunction. So this formula here, and I'm just using this formula as an example. I'm not going to demonstrate this whole method, okay? But so that formula to derive speed from a constant bearing is own speed times the ratio of the sine of the bearing over the sine of the angle on bow. Okay, so now you can see we've got both multiplication and division here. So the way the slide rule handles multiplication and division is you start with the division. You say own speed divided by angle on bow. So that's how you set it. So we already know how to do that. We say, let's say our speed was 3 knots. Okay, so I find 3 knots here, and let's say the angle on, we'll use this example, I guess. Let's say we're going 2 knots and the bearing is 280. Okay, 280 is actually 80 degrees from our bow, so the bearing is really 80. So then, the angle on bow, is 20. So I'm starting by doing the division, own speed divided by angle on bow, and you will then see the multiplication aspect of it as well. So own speed 2 divided by angle on the bow of 20. I take 2 and I set it opposite 20. The easiest thing to do with this, since once you depress the left mouse button, you can move it wherever, and it will your mouse wherever, and it will spin the dial. So for precision, I suggest getting right on the number, and then holding, clicking and dragging, and then just putting it on the actual tick mark that you want, just like this, so you know it's accurate. Okay, so 2 divided by 20, 2 knots divided by the sine of 20. Okay, now to do multiplication, I then look at the, say I'm multiplying that by the sine of the bearing, so that's the formula. Okay, own speed divided by angle on bow is the first piece times the sine of the bearing. It's a little wonky, the order of operations, but it's for the slide rule, it makes sense. Own speed divided by that times the sine of the bearing. So to do multiplication, I don't do any spinning. I just look and I say the bearing was, I think it's at 80, right? 280 is 80 degrees. So then I just come up and I look at 80. And to do this, it might be easier to just for alignment, just to line up the 80 and then read down the answer here. So 5.6, 5.75, or 5.8. Okay, so 5.8, there it is right there. So that's the multiplication. The multiplication is simply just taking having set your disks in some fashion, going and referencing. Now, what if you don't have division involved in it? I should have started with a simpler example. So, like, take the example of the distance to track calculation. What that is it's range times the sine of the angle on bow. So that's simple multiplication. There's no division involved there. So what you say is, okay, range times the sine of the angle on bow. Let's say the range is 5,000. I see a target's 5,000 meters away, and I want to know when that target passes me how far away I am off of its track. So to do simple multiplication, I should have started with this example. Assuming no division, since the sine of 90 equals 1, you set your value to that, because you're not. So what you're saying is I'm dividing 5,000 by 1, i.e. I don't want a different answer. I want 5,000. 5,000 divided by 1 is 5,000. So I set that value, if I'm not changing it by division, I set that value to 90, and then I simply read off. I'm turning this just for reference, so I can read down easily. And I say, okay, the angle I at 5,000 meters now, and its angle on bow is 20 right now. How far am I off its track? Set 5,000 against 90. Do the division. 5,000 divided by 1. The sine of 90 is 1. 5,000 divided by 1 is 5,000 times 20. So I multiply by 20, and I get 1715 meters. I read off the answer. So that's multiplication. So again, division is setting, on a slide rule, is setting one thing immediately against another thing. 5,000, here's 5,000 divided by the sine of 7 would be this. Okay, that's how you would set that. And then you would, assuming whatever else was in the calculation, you'd read it off someplace else. Okay, or to use this time, speed, distance, my target went 1,400 meters in 2 minutes. Boom, 1,400 over 2. Read the speed off the reference line. In that case, it would be 23. And so that's division. Then multiplication, assuming you're not doing any other division or anything like that, you simply set the value, the first value you want to multiply, against 90, because you're still doing division, but you're dividing by 1 there, which is essentially not doing any math. 5,000, and then you read off whatever you're multiplying by elsewhere on the disk. That is multiplication. So that's how to use the slide rule. Just so you understand that, because the best way to do it, and I didn't really get good at doing slide rules until I learned to start with the formula in your head or whatever, or look at it, and then you'll know how to use the disk. You know what to line up with what by whether or not you're doing multiplication or division or whatever. So that's the long and short of how to use this mechanically. And then in the coming examples, we'll see how to use it in practice. The other thing to note is, and I kind of stumbled on it by doing this last sort of ad hoc example, but I used to demonstrate that last division, I used 1,400 meters in 2 minutes. So just imagine if it takes you 2 minutes to go 1,400 meters, that divided by that, wait a minute, the target's only going 2.3 knots? No, the target is actually going 23 knots. So the thing to be careful about using the slide rule like this is that you need to have an understanding of expectations from your answer. So you should know that 1400 meters, 2 minutes, 1400 meters, 2.3 is probably not the right answer. I need to move the decimal place over 1. It's 23, between 22 and 23 knots. Be very, very careful when you're using this to not necessarily take these at face value, but you may need to correct the decimal place based on whether or not your answer makes sense. And I'm glad I stumbled on that example, because I'm not sure if I would remember to mention that, but you know, you need to use a little common sense when you're doing this to understand that you may have to move the decimal place. Another example of this is when we go over finding target speed by the fixed wire method. These range rings here are also a proxy for target length. However, you need to move the decimal place over 1 to the left. This is 140 meters long. This is 150 meters long. It also could be 15 meters long. Just understand that because the relationships are all the same, you may need to you can move the decimal place back and forth and still derive answers in this, but you just need to know that what you're doing in terms of what your expectations are and what the information is that you're trying to both input and what the information should be that you're getting out of the disk. So so that is another important point. So so with that, we'll call it good for this first video. This is just meant to introduce the disks and just to tee up the further. I think I'm going to do 4 more videos in this series covering really an engagement in Wolfpack from A to Z, from soup to nuts, so to speak. But this hopefully gives you the background of this. There's plenty of documentation about the use of this particular side of the attack disk out there. There is also documentation of how to use this. However, I have not seen a lot of people explain the mechanics of using the slide rule as far as division and multiplication is concerned. So that's why I really wanted to cover that aspect of it, to sort of drive the point home of why you're doing the things you're doing on here, why you're lining one up with the other and looking someplace else to get another value. It's because you're replicating multiplication and division on this on a circular slide rule. So with that, I will call this video good, and I will see you in the next installment.